Assalamualaikum warahmatullahi wabarakatuh. My name is Nurshafawati Binti Rosnizam, metric number CD190118. I will present about Chapter 1, Introduction. A control system is a group of devices that work together to coordinate, order, direct, or govern the action of the other device or system in order to accomplish a specific purpose. Learning outcome. First, conduct experiment, record and analyze data. Second, determine the relationship between temperature and humidity. Lastly, to produce a good conclusion from the experiment conduct. Our objective is to study about temperature and humidity using Arduino Mega 2560. Second, to understand how to design using Tinkercad. Lastly, to comprehend the role of each system component. For skill is Arduino is a platform for creating electronic project. Arduino consists of a physical program circuit board and IDE software for developing and uploading computer code to the physical board. Our scope is using Tinkercad, create and execute a simulation for a temperature and humidity sensor. Second, to create a temperature and humidity system with the addition of a LED and a buzzer. Lastly, apply control engineering and electronic expertise and theory to the system. Our material is Arduino Mega 2560, buzzer, yellow LED, DHT 11 sensor, jumper wire, breadboard, and lastly HDMI cable. That's all from me. Thank you.
Hi, my name is Ong Wei Cean, matrix number AD190218 from section 5. Today I'm going to talk about the procedure of our experiment. First of all, the circuit is constructed by using Arduino Mega, breadboard, jumper wires, resistor, LED, buzzer, and DHT11. In the Tinkercad, there is no DHT11 component, so I replace it with DMP, which has almost the same function. 2. Buzzer and LED are connected with jumper wires to the Arduino Mega and breadboard as shown in figure beside. 3. The basic components such as Arduino, breadboard, buzzer, resistor, LED are placed by using Autodesk Tinkercad. 4. As indication, black wire indicates negative source and red wire indicates positive source. 5. The red jumper wires are connected to the 5-volt pin while the black jumper wires are connected to the ground pin of Arduino. Next, the output pin of DMP is then connected directly to the analog input to make sure that able to read the temperature value from the sensor. 6. The LED is connected with black jumper wire and the resistor. The resistor must be connected at the negative pole as it is the main source of transmitting electron. 7. The buzzer's negative pole is connected at the breadboard, while the positive pole is connected to the Arduino second hole. Finally, the LED will light up when the temperature of surrounding exceeds 33 degrees Celsius. The buzzer will produce sounds when the surrounding humidity is low.
Hello, madam. So today I'm going to explain about our project, which is done through the Arduino Mega. So first of all, we have included the DHT.h to access the DHT library, and then we have defined the DHT pin for port 3, and for LED it is port 9, and for buzzer it is port 10, and we have defined our temperature sensor as DHT 11. Then this is our coding to read the temperature and the humidity for the sensor. And then this is our coding for the LED. So when the temperature rises above the 34, the LED will switch on. The high means the LED will switch on. Same goes to the buzzer, where when the temperature goes below 31, the buzzer will switch on. And then finally, this is our coding for the output. The humidity and temperature. So now here, this is the output here. That's all.
Assalamualaikum and hi, my name is Jannah Binti and Rodzi. My matric number is DD190054. Today I would like to present chapter 4, which is discussion analysis. This slide I will go through so fast. So for the first, the humidity level detector system function as our group expected. For the point number 3, if there is no heat, no signal is translated to electrons, and so no lights or warning sound is created by LED and buzzer. For the point number 4, when our experiment undergoes the heat is detected, the temperature increased from 32 degrees Celsius into 37 degrees Celsius, which will light up the LED, and the buzzer will produce sounds. It shows that the humidity is low. So from our observation, when the temperature is high, the reading of humidity percentage is decreased from 74% into 72%. For the second slide, the humidity level detector system before and after shows that in the picture in this slide, we'll say that the buzzer will produce the continuously sound until the temperature decreases below 33 degrees Celsius, which is the room temperature. It's important to notice that the both temperature and humidity decline at even the smallest changes. As a result, the relationship between temperature and humidity is inversely proportional, which indicates that as the temperature increases, the humidity decreases when heat is detected. Last but not least, for the third slide is analysis. So it's just like Q&A. We choose the question, which is prove a third example about the relationship between temperature and humidity charge in daily life. And the second one is what it was the difference between DHT 11 sensor rather than DHT 22 sensor. So that's all from this slide. Thank you.
Hello, my name is Nurul Amirah Binti Norizam, AD190135. So in this video, I will be conclude all our project. So in our project, we have used a sensor module that is called DHT11. This module features a humidity and temperature complex with a calibrated digital signal output. DHT11 provide accurate humidity and temperature readings as well as great dependability and long-term stability. We also add on with buzzer and LED into our project to determine the changing of temperature and also humidity. The function of LED is that it will light up when the sensor been tested with temperature that is above 33 degrees Celsius, while the buzzer will make a sound if the humidity is at low. So based on our project, we have observed that the initial value when in the room temperature, such as the humidity is between 71 to 75%, temperature is between 32 until 33 degrees Celsius, and also humidity index between 44 into 45 degrees Celsius. Lastly, we can conclude that when the temperature increase, the reading of humidity percentage will be dropped from 74% to 72%.